Hey all, thank you for joining. Let me go ahead and share my screen. I will just quickly share the slide. Okay, so today we're going to talk about running Armada, which is basically an operator on top of Airflow across multiple clusters. And we have with us Kevin Hennon. Kevin is an open source developer with G Research. Kevin did an awesome presentation on this during our Kubernetes community days in September. We have a recording of that available, but obviously it was not good quality, and we wanted more people to look at this. It's a good topic. Before we get started, quick housekeeping items that you can join our community on slack.kubernetes.io. Look for hashtag meetupdc channel there. And we were just talking about this, that we fully use the community.cncf.io/Washington-DC page. This is where you can register and get updates on future events. You can also go look at the past events, the recordings, and slides as well. We have a DC Kubernetes Meetup YouTube channel where we upload all of the recordings from these events. With that, I will go ahead and stop sharing and then have our speaker basically present. And for questions, you can ask questions by just, being on video, or if you want to post a question in chat, we will also interrupt Kevin time to time to help get answers, or we can just wait for the end and answer all questions at the end as well. All right, Kevin, you're ready? You want to try sharing your screen? Let's see if that works.
Yeah, I'm having some problems. Is there any? That's annoying.
Okay. Do you have to restart?
Yeah, I might have. It says, yeah, I'll try restarting the browser.
Yeah. All right, that happens. We were just chatting. We should have tried screen share before.
Might be wrong browser. It looks like for
Yes.
me in Firefox. No,
Yeah.
in Firefox it works.
Okay. All right, Kevin is back. All right. Okay. While we're waiting on Kevin, just a heads up that we will not be having any meetup in December, but we do have one planned for January 10th next year. So, and that is going to be around using build packs and container automation. We have a solutions architect from VMware team who will be presenting on that topic. So look forward to that announcement. We will announce it on the community page as well, CNCF community page, as well as in the meetups. All right. All right, we can see it. Kevin, you're on mute, but we can see your screen.
My bad about that. Sorry about that.
No worries.
All right, we'll see how this goes with the demo. I'll figure it out. All right.
All right, so you ready?
Yeah, I'm ready.
All right, good. Take it away. Thank you, Kevin.
All right. Thanks, everyone. Yes, I can't see the messages, so if anyone messages during it, please, you can feel free to ask questions during the call or during the talk. This is pretty informal, so just feel free to ask any questions as. But so I'm happy to come back and give a talk to this group again. I really enjoyed presenting at the DC community or Kubernetes Day a couple months ago, and I was excited to come back. For those that attended, this is a similar talk. I was hoping to try and do a bit more demos. We'll see how my how this sharing platform is going for otherwise I still have a good amount of talking to do. So in general, I'm talking about Armada, which is a recent project in the cloud native sandbox, and it's basically focused on enabling the scheduling of batch workloads across multiple Kubernetes clusters. So I actually started my career in chemistry, and I focused on writing scientific computing programs to describe chemistry, and it kind of got me into the high performance computing or parallel computing area, and I really enjoyed that, and then I decided to go away from that because did not want to finish my PhD. So then I decided to go. I was a software engineer for a few years, but in the probably last year, I started getting more involved with running batch workloads across Kubernetes or high performance computing clusters. And then probably about 6 months ago, I actually joined G Research to fully spend my time trying to improve Armada and in general the Kubernetes ecosystem for running batch workloads. And so I'll introduce my employer next. So G Research is actually a financial technology company that's based out of London. They kind of are a large trading company in London. They have a pretty big presence for talks and hosting various different tech talks in London. And in general, they just recently opened their first US location in Dallas. But for the purpose of this talk, all you need to know about them is that they are primarily focused on enabling a wide range of researchers to run quantitative analyst jobs, quantitative analytics, and that can range from ET, machine learning, and then even some other type of workloads like that. And in general, they have a pretty large research cluster for researchers to submit containerized jobs. So to start off with, what exactly is a batch job? You'll hear a lot of people mention different use cases, but for the most part, it is a finite job that usually it kind of goes against the paradigm of Kubernetes, where Kubernetes was designed to run persistent or to run microservices and keep them up and running. And batch jobs are basically kind of the opposite of that, where you might want to run a job for 60 minutes and then it is complete, and then that doesn't mean the job failed. It just means it did what it's needed to do, and then and you're done. So that it's kind of a different paradigm for Kubernetes, because I remember my first time trying to create a pod in Kubernetes, and I probably created some kind of a Python job that ran a script, and then it just would fail, or it would run, and it would say, oh, hey, you weren't running anymore, so it failed. And that was kind of a different paradigm shift for me for trying to run on Kubernetes, but figured it out after a while. So in general, batch jobs I would say they range from, you can have computational science, which is where my background's from, where you have molecular modeling, protein folding, computational fluid dynamics, and really these are just specify a series of inputs, run an executable, and then eventually your job will finish, and there might be a lot of logging, but usually it's pretty well self-contained. Obviously, machine learning is another big one, especially for model training. And then also another common case is ETL or ELT data workloads, like pulling data from some cluster and then doing some kind of transformation, loading it somewhere else. That is still a batch job. And then my last role was actually working at the National Institutes of Health, and one of the big focuses in the scientific community was on containerization, and a big proponent of that was actually the genomics community. So I did want to give their community a little bit shout out here, because I do think that they have a lot of interesting running containerized jobs for gene sequencing, and they also do a lot of part about releasing these tools for researchers to use, and so that is another area that is modeled well by this idea of batch compute. So in general, one of the things I like So for running batch jobs, there's kind of, I like to think there's two different ways of how, or if you want to kind of split your workload up. And one is, and try to get your workload to finish faster. One is called this embarrassingly parallel, which you might hear people call it simple parallel, but it's this idea that you can split your job into a series of tasks, and then you can process them independently, and then just kind of gather all that data together. This is kind of similar to the map reduce paradigm. And in general, a lot of tooling can handle this pretty well. You can use this with simple bash scripts if you want, or in even Kubernetes, you can do this with the job API relatively easily. And it usually is the first thing that people tackle when they're trying to do parallel computing, because it's, you can imagine a for loop, and then you just spread your data for each value of the for loop, and then you're now distributed, and then you can gather them together. So pretty simple pattern. The hard one is actually more of the what most people could call the parallel computing, which I guess the other one is parallel computing, but I would call this more of like that's traditional. Actually requires communication between processes in order to speed up its computation. So this is a simple, basically you can imagine for a traditional use case could be a user wants 2 dedicated compute nodes, and then they want to have communication between them. And an older way of doing this is called the message passing interface, or MPI. This is kind of a way to send messages between different processes. And if you're within a node, it can be shared memory, but it will most likely for this purpose be cross node. So it will be internode. And then also what is becoming more common is GPU to GPU communication via MPI. So you can communicate between different GPUs for AI, for ML training or some purpose like that. But in general, this is much harder to do. This is a lot of communication, containerizing this, and having both your containers talk to one another via processes gets kind of complicated. And this is kind of a pattern that is not really there are solutions to do this in Kubernetes, but it is not really effortless. And I want to so we're all familiar in this group with Kubernetes. I want to kind of shift gears a little bit and talk about like kind of how a academic researcher or a research scientist or a computational scientist would interact with a cluster. And this is kind of a common pattern. This is a common pattern that I first learned about how to submit calculations to, and it's still very common today. So I'm talking more about like a high performance computing cluster. So typically what a user kind of logs on to they have a proposal, they get some compute time for a cluster, they're given access credentials for the cluster, usually via SSH, and they get some kind of special key to get in through an RSA or whatever. I don't remember what they do now. But in general, you can SSH into a head node, and then now on that head node, there's usually some kind of high performance computing scheduler. I will talk about a couple options, but the most common one I've seen is Slurm. And they typically have some job they want to run, and they know how many resources they want for their job. Like say they want 4 nodes with 8 cores each, and they want it to run, and they want this amount of memory, and they want nodes that have a lot of memory or a lot of disk space. They kind of put this in a request to the scheduler. Then they queue their job and wait for them to have those constraints, and then now they're able to run their calculation on those nodes. And that is kind of usually handled via the scheduler. And then in the high performance computing, there's also storage and network. So the idea is that these nodes are most researchers are used to them being physically located in the same data center. And then they typically have some kind of higher speed network for fast communication, for the cross node communication. Then they usually also have some kind of shared volume that all these exec nodes can write to. And then also this is how users can input data into the cluster and take data out of the cluster. Excuse me. So basically the common pattern, as I was saying, for schedulers is there's usually like these hooks to a scheduler. So Slurm is on the left hand side here. This is kind of how you can specify your job name, your task, your nodes, your wall time, and then also what kind of executable you want to run and how you want to run it. Usually they're pretty much just bash scripts that you can just submit. And then I am calling out another one called HT Condor, which comes more from the high throughput, because my employer was actually originally a big Windows.NET shop and they actually originally had an HT Condor cluster for running batch jobs on Windows. But in general, they're both very similar. Like, you have some kind of executable, you have resource requests, and you have where you want your log files to write, and then some kind of queue that you want your job to be queued to. So I just wanted to the scale for a lot of these really large supercomputers can actually be quite a lot of cores. I took a snippet of from I think this was from July. It was from May last year, that this is the top 5 supercomputers in the world, and number 1 is Frontier at Oak Ridge National Lab in Oak Ridge, Tennessee, and you can see the amount of compute is around 8.7 million cores, and this is quite a lot. And if you wanted to try to build something similar to this on Kubernetes, you could think, well, that's crazy, but that's sort of why I wanted to show this, is to kind of give an idea of, like, if you wanted to build a supercomputer running with Kubernetes and you wanted to kind of be close to what this list is, you can see how much compute you want to sort of target. So yeah, so in general, what G Research wanted to build was they want researchers to run a large number of batch jobs, and it can range from, they want to run a large number of batch jobs, and they want them to run they want to be able to submit a lot of jobs over a short amount of time. And to give you some like historical context, I already mentioned that HT Condor was our original cluster, and this was for scheduling batch jobs on Windows. Part of the reason why we started migrating to Kubernetes was trying to take our organization from Windows to Linux, and then also start adopting containerization. But they had all this tooling built around scheduling batch jobs on HT Condor, so they decided to kind of build a replication of that on Kubernetes, so that they can make the transition easier for their users. So in general, what they found was that they still need a queuing solution, so some kind of way for users to submit jobs that can hold those jobs in a queue somewhere and then run them on a cluster somewhere. And then in general, they wanted to target around 100,000 nodes up to about 1 million cores, and have a lot of GPUs for the ML users and other types of users. And they have a wide range of either single core to multi-node jobs. And we also wanted to provide a UI for our users and admins to be able to walk them through what jobs are running and all that. Let's see. I'm going to see if I can share again. Not share. Let me see if I can share again. All right. I might not be doing demos this time.
Do you have to allow individual apps?
No, I just can't. It's not letting me share the entire screen. It just says it's not allowed. I can do the Chrome tab, but I was going to give just a terminal demo, but I don't think I can do that if I can't get the screen. Oh, hold on. Nope, I can't share. I can only share the...
Uh-oh.
That's unfortunate. Well, it will be a demo list. One. If anyone, I don't know why it won't let me share the screen.
What browser are you using?
I'm using Chrome.
Okay. So sometimes when you go to share, there is is anybody else using Chrome? Maybe there's a separate section. I'm using Firefox. So Let me think. Oleg, are you using Chrome?
No, I'm on Firefox as well.
Yeah.
Moreover, I looks like I logged it
It's all
out
right.
of screen sharing too.
It's all right. It's not a big deal. I have a little. It'll be okay. No worries.
So when I use Chrome, right, and I do share screen, up top it gives me choose what to share, and then there is entire screen, window, and Chrome tab. There are three selections.
Yeah. No. When I do entire screen, I click share. It just says we can't access your screen. Check system settings and restart your browser. But it doesn't say.
Oh,
It doesn't say what it's trying to do or what I need to enable.
so you have to go to system settings. Are you on Mac?
Yeah.
You have to go to system settings, system preferences, and then you have to go to privacy, security and privacy, right?
Yeah.
And then inside that, you have to go to, let's see, screen recording setting.
Is that under privacy? Oh,
It's under privacy, yes.
I don't see that. Oh, yeah.
So it's like scroll down from there's location services, context, calendar, and the privacy tab. Keep going down, there's screen recording,
Oh, here we go.
and then there's going to be Chrome in there.
Okay. All right. Now
You
I
have
see.
to, you can
Okay.
rejoin. Yeah. All right, sorry about that, folks. Hopefully it'll be more interactive once we have the screen pulled up. All right, Kevin has joined. We can see your screen. Yay! You're on mute, but you can unmute and then.
All right. Great. We're
All right,
here. Thank
thanks.
you.
Yes. All right.
So, what I just wanted to kind of walk through was when I first started learning about multi-cluster, I was a little confused at how you actually can get uh, Kubernetes in a multi-cluster and how that all works. And I wanted to just and so in the in a previous slide, I kind of talked about the Kubernetes job API. So I want to give a little demo about the job or scheduling a batch job on Kubernetes and kind of what that looks like. So let me make sure I have everything set up.
Hey, Kevin, can you make this like font slightly bigger? Maybe you want to maximize the terminal too, just so that. Yeah. All right, there
Is
you
that
go.
better?
Yeah, it's better, much better. Thank you.
Okay. So I'm using Kubernetes and I'm using Kind, which is Kubernetes and Docker, to kind of give a quick demo showing. That's what I'll be doing for the demo today. But it's a pretty nice lightweight way for running a Kubernetes for testing purposes. So sorry. So what I wanted to so if I wanted to submit oh come on. So what I wanted to send. So if the way you can do, so if you want to submit or deploy objects to different Kubernetes clusters, you can actually use this Kubernetes context. And so Kind automatically names it. It has Kind, and then you create a Kind cluster. It's called Kind, and for some reason it prepends Kind to it. Don't really know why, but that's what it does. So what this is doing is now I have submitted a job to my Kind cluster, and you can see here. So a job is a higher level controller that kind of basically makes sure that you have your pods running. And so you can see I have a a job object, demo job, and this completions 1 of 1 means that this job has finished. And then jobs always can create pods under the hood, depending on how many pods you want to run in parallel. That depends on how you set up your job. You can see here I've submitted a job. This is just simple sleep jobs, and then it reports great. So now if I wanted to, I want to clean this up so I don't forget about it. Now if I want to submit to a different cluster, I can simply change my context, MOA, and then the idea is that in order to monitor the progress of this job, you can obviously you can always use the get API with the right context, or sorry, the kube control with the right context to view the state of your job. And this is kind of at a high level what Armada is doing with scheduling across multi-cluster is we're changing which Kubernetes cluster we're actually submitting a pod to, and then we are monitoring the progress of the job via some kind of API. So that's kind of when we talk about multi-cluster, like this idea of you can tell your kube control or you can tell your Kubernetes API which cluster you want to run a pod on, and then you have to make sure the user knows, without knowing what cluster they're actually running on, what happened with the job. So that is at least with the job API, and that's sort of, and then to give you all, as you're clear, my job is pretty simple, running a single pod, and it sleeps for 10 seconds, and it gives a resource request. And so, all right, without further ado, I'll go back to my talk. Okay, yeah, so this is all I wanted to kind of give an overview. So for Kubernetes, you have this job API, and this is kind of the de facto standard for running batch jobs, or it's trying to be. And under the hood, it does schedule pods, but if you, most people probably here know, Kubernetes like 101 kind of talks about you should not schedule raw pods to a cluster. It will, if your node goes down, you lose that pod. You want to use some kind of higher level controller, like a deployment, a job, whatever. And that kind of provides that self-healing capability. And the job's kind of the same way. Like if a node fails in the middle, and in Armada, we do have problems where nodes will fail, and we want some kind of controller to retry that job. And that is kind of the point of the job controller. So now, why do we even why did we create our own project? Why does this not work with Kubernetes? Well, there are a couple points. One, trying to support a large number of nodes on Kubernetes is actually pretty hard. This blog post by OpenAI actually talks through a lot of the problems they experience when they try to run Kubernetes with 7,500 nodes. They have another blog post where I think they ramped it up to 2,500, and it was very interesting to learn how they reconfigure the Kubernetes API server and a lot of different things, and also add a lot of metrics to figure out what's happening with their cluster and basically operationally support that. So there's a lot of effort there. It's not really what everyone wants to do. And so actually in G Research, we actually cap our nodes to, I think, around 1,000 nodes per cluster. And in general, the other area is when you have a fixed number of resources, which I know the cloud likes to say we don't, but we do, whether it's fixed money or if you're on-prem, you actual physical hardware. You want some kind of way for your users maybe a new user can submit a job ahead of someone that's like swarming your cluster. But in general, you want some kind of queuing system to take your jobs, run them at some point, and then make sure that you have some kind of priority. But in general, for doing like scientific computing or parallel computing workloads, the job API really was not designed for that. It was designed for pretty short-lived jobs, and it really was not designed for a large number of jobs with a queuing system. And the other area that is also like for MPI or sort for any kind of parallel job, you probably have multiple pods. You want kind of a grouping of scheduling to be done. So you want, let's say, 4 pods to be scheduled on one cluster, and you don't want your object, or you don't want your job to start unless all 4 of those are scheduled. That's called, in this community, it's called gang scheduling or all or nothing scheduling. And this is actually not done natively in Kubernetes. And that becomes kind of a pain point. So a lot of controllers for different parallel jobs actually do implement this, but it's kind of up in the air about what is the best way to do this. So in general, there are 2 big projects in this, or not big. I like to say Armada is big, but that's the story for another day. The larger one is Volcano, which is actually an incubating project in the Cloud Native Computing Foundation, and they took the approach of extending Kubernetes via custom resource definitions, but they are primarily single cluster, and they actually created their own dedicated scheduler for running batch jobs. And then there's also Armada, which obviously is what I'm talking about today. So Armada is multiple Kubernetes clusters, and one of our main design patterns is to use our own scheduler, or sorry, use a native Kubernetes scheduler as opposed to write our own. So in general, yeah, the high level solution for Armada is we want to use multiple Kubernetes clusters. We want to use a native scheduler in Kubernetes, and we actually decided to use pods rather than jobs to give more flexibility. We might be revisiting that design decision in the next few months, because it does look like the job API has gotten a lot farther along. And then one area that the architects decided on Armada was that they found that a lot of users actually were submitting large grouping of jobs rather than opposed to individual. So they actually provided a way for users to subscribe to their own jobs so that they get notified when certain jobs are complete, rather than having a polling loop to keep polling each individual job. So for Armada, we have kind of this idea. We have 3 concepts, really. A job is actually more than just a pod. I will give a demo later talking about submitting Jupyter notebooks to Armada, and that actually for Kubernetes, that requires a pod spec, a service, and an ingress, all being scheduled as part of a batch workload. So in general, our job is usually a collection of Kubernetes resources with labels and queue or annotations, and also what queue you want to submit this job to. Then there's job sets, which is our grouping of jobs, and then queue, which I've already talked about. So in general, the high-level architecture for Armada is that there is kind of this higher-level API gateway called the Armada server, and we provide APIs through gRPC that allow users to submit jobs via the API server. And then we have event database and job database to control state and have users know which jobs are finished running, and be able to build a UI on top of that. But in general, the Armada server for running workloads, the way we horizontally scale our needs for compute is actually through this concept of the executors, which are, like, you can think of them as Kubernetes worker clusters, where you have they're the dedicated clusters for actually running the pods once there is capacity. And in general, if you want, and one of the reasons why we wanted to go with this approach is we wanted to be able to be fault tolerant to bad Kubernetes clusters or bad nodes, and be able to add new clusters at will, and also maybe potentially have multi-cluster, or we are multi-cluster, I would say, clusters, maybe different locations, or be able to burst certain calculations into the cloud if we need to. So this was kind of a pattern. There's also one benefit of multi-cluster is really this idea that you don't have to completely update all your cluster at once. If you have a bad config change, you can completely block your users from being able to submit calculations. And so what they wanted to do was be able to roll out changes for the executors and be able to have rolling deployments, and also make sure that you don't take your cluster down all in one go. So yeah, so a queue is pretty much, in general, it's priority and resource limits. And then we also have some role-based access control for allowing our users to give permissions for what they can and cannot do, depending on the user. We're a fintech company, so we are very strict on security. So there's a lot of role-based access control for what users can, or who is allowed to watch which jobs, and who is allowed to submit jobs, and who can cancel other jobs. So this is why a lot of this stuff can be built in. And so in general, our job spec, I mentioned that we are more than just a pod. And in general, like I did not show services, but I have an ingress and a pod spec. The pod spec is a container, or it's a pod template really, and you're allowed to, and it's pretty much whatever the Kubernetes API takes for the pod template. So you can use things like taints and tolerations, and you can add volumes, and you can add a lot of things to a pod template. And that allows us to get all the flexibility of running pods on Kubernetes. So we were actually, G Research was a Windows company, or they still are transitioning from Windows. So one of the first clients we actually built was a .NET client to allow users to submit to calculations via C#. We also just recently released a Python client, and I will give a demo showing integration with Airflow and Armada via our Python client. And then we also have a CLI that allows you to kind of create queues and submit jobs, similar to how you would do that with kube control. All right, I'll give a demo of those later. And so in general, for Jupyter, the idea is that you have users Jupyter Notebook is this interactive environment for users to run Python code, and you can actually have a lot of kernels. I was very blown away when I found out a few years ago that you can actually run C++. You can actually write C++ code in a Jupyter kernel and have it compile. I thought that was pretty cool. But in general, the main use case for Jupyter is Python, and R is a big one too, where they provide these kernels for people to run interactive data science jobs. And it was one of the first use cases we had asked for Armada, was this idea of being able to submit a calculation to Armada and then be able to kind of log on to the Jupyter Notebook, or basically have it open up in your browser, but be running on Armada rather than on your local laptop. So I'll give a demo of that too. And so for observability, we have a UI that kind of gives you information about what queues are running, queued, pending, running, and then some information about that. We have 3 views for our Lookout UI. One is overview, and then we have a job sets and a jobs. Again, we allow the grouping of jobs via job set, and then the job view gives you information about a particular job. So in general, the top banner here is the job set view, which kind of just gives you information about all your job sets, which are running, and just general information. And then you can drill down into the job ID and get more information about the state, or what the YAML was, or what the errors were. And so roadmap, we are always open for user requests. We are an open source project. So if anyone is interested to ask like what features are coming up, please feel free to file GitHub issues. But in general, one of the main focuses we're actually working on is adding the ability to support gang scheduling, which is to support parallel jobs, and preemption is another one. And also we're going to be probably doing a big release of a new UI to help provide better observability and admin support. And then we're also always looking for more integrations with other open source software. And so I wanted to kind of give a shout out to a couple different groups. The last bullet point is obviously our GitHub page, and then we have as part of the CNCF now, we actually have a Slack channel it's under the CNCF Armada. And so if you are starting to work on Armada or playing around with it, I would please ask to post any questions on there. It's a little quiet right now, but we will definitely answer any questions that people have for getting started. But in general, one of the coolest things that I've been seeing the last year is actually a huge focus on. A lot of people have said that it's very difficult to run batch workloads on Kubernetes. So the Kubernetes community has actually created a working group that is filled with people from SIG-Node, SIG scheduling, and SIG apps to improve the job controller and the job API, and to also add new APIs into Kubernetes that will enhance the users for running batch workloads. It is an interesting approach, and I have been starting to get more involved in trying to find problems where I found in Armada that I know everyone else that has run batch workloads on Kubernetes has also discovered, and we've been trying to get those more into the public on the Kubernetes side to hopefully get some of its features merged upstream. And then we also have, there's a research user group. So if you're someone that is focused on running research workloads on CNCF projects, it's a good group to hear about different use cases and also some various research areas that are coming up with CNCF. And then there's also a batch working group under the CNCF where the focus is right now we're trying to gather best practices for batch. There will be a survey sent out in the CNCF community to get information about how people are running batch workloads on Kubernetes. We're hoping to write a series of blog posts or papers about best practices for running batch, because there's a lot of, I would say, tribal knowledge for people that have experience running Kubernetes with large number of batch jobs. And I think it feels like there's a lot of, it would be good to get this information out into the public rather than each person figuring it out their own way. All right, without further ado, I'll go give hopefully a short little demo, and then I'll leave time for questions. Sorry, give me a sec. Can you all see my visuals?
Yeah.
Okay, great. So I have this kind of running on a cluster with a single kind cluster just to make it easy for demoing. Okay, everything looks like it's good to go. So in general, as I mentioned, there is a CLI that we can use for creating queues, for creating jobs, submitting jobs, creating queues, called the Armada control. I'll just go ahead and create a queue, and I will submit a couple jobs. So in general, what I'm showing is, what I wanted to show is a couple jobs to submit. So in general, like annotations is actually a pretty common pattern for our users to give more information, to add more information to these jobs. We provide a nice way for this to show up in the UI. And then also this is just a simple sleep job. And then also run Jupyter. So in general, you can see these are all very similar to what I showed in my talk. There's a pod spec, some kind of command arguments. And what I wanted to show with Jupyter was this idea of we have an ingress service, node port service, and they're all listening they're all exposed to port 8888. And then a Jupyter Lab instance that is running so the UI is here. So in general, you can kind of see these jobs are submitted, and if you're curious, these are actually running as pods. So you can see I have 2 of these jobs have finished running, and then one, this is my Jupyter job, is still running. And the UI actually does show this information too, but we did not really want every user to have familiarity with using kube control. So we have one job that's pending. I can go to jobs here, and you can see this is Jupyter. as I said, this was pretty much you have a pod, and this gives you information about what the queue, the owner, job set, and information about where the job ran. And then also this allows us to add some annotations, and then we add some stuff for like hyperlinking, so or be able to open up a new browser if the user wants this to go to a URL, for example. This is popular for like logs and things. In general, that is for the simple UI. And then what I wanted to show was, since we actually submitted a pod, we submitted a pod service and ingress, I actually want to log into that, or I want to be able to show the Jupyter stuff. So in general, I don't have an ingress working on kind right now, so I'm just going to port forward, but we actually do provide an ingress URL usually for these jobs, so users can just open up a browser once they know their pod name. So all I'm doing is exposing the service, and I'm now able to go on to the on my EC2 instance URL to view this cluster. So this is Jupyter, and I think if I remember the password right. So this now I am actually, this pod is running on my kind cluster, and then I'm able to this is a fully interactive environment, so I can actually run some Python code. And what is nice, this is actually a TensorFlow notebook. So if I, using the Python magic commands, you can see this is a actual pretty hefty Python virtual environment for running TensorFlow. So, and then the last thing I wanted to demo was Airflow. So for those that are not familiar with Airflow, one of the ideas is that Airflow is an orchestration system, and one of their strong points is that they are not really designed to run compute. What they want to do is be able to have users maybe say, like, I want a Spark cluster, and then a Dask cluster, and then Kubernetes, and I want to be able to orchestrate a workflow, and then be able to run it in different environments, but still have the workflow orchestration part handled via Airflow. So what Airflow is I can show you the code. It is really a Python script that is kind of, I would think of it more akin to a config file, and it provides you, typically Airflow provides this idea of operators, which is how you actually run the execution on whatever environment you want. In order to support Airflow integration, we actually created an Armada operator. But in general, we can create a simple pod definition, and then we specify a DAG, and then this is some information for us. And then the syntax for Airflow is this idea of, you can specify a DAG, and this is what this is saying is I want to run a bash, this bash operator, and then I want to run my Armada job, and I only want to run my Armada job if my bash operator is successful. And what's nice about Airflow is you can actually do a lot of scheduling, and a lot more sophisticated scheduling for cron, or running on a consistent basis. Now, not using that for that right now. I will just show a simple execution running manually, and hope it didn't fail. Okay. Sorry, I have to. What happened there? So in general, trying to run. All right, well, this seems to be working today. In general, with Airflow, you can there's different DAGs you can specify. So I have this special Air one, where the idea is that I can run these two different tasks in parallel. And then, but if I only want, what this is saying is I want all two of these jobs to run successfully before I go on to the next job. And that's one nice thing about having integration with Airflows, we can have actually some open source solution handling a lot of the orchestration for us, and then we can have Armada be focused on running compute across multiple clusters. And unfortunately, I don't know why it stopped working today, but I'm close to time, so I want to leave some time for questions. And yeah, that's it for my demo. Does anyone have any questions?
Interesting. So is Armada, when it uses essentially Kubernetes job primitives to run jobs, but does it add to so on top of what they provide, like Kubernetes job, for example, can, if I'm not mistaken, rerun for several times until it gives up, something like that. So Armada uses that, right?
Yeah, that's one thing we're actually trying to actively go towards. I think we started the Armada project in 2019. And at that point, there was a lot of problems with the job API, and a lot of the community actually would schedule raw pods rather than the job API. So we are actually we are in the early stages of trying to migrate or start considering migrating to using the job controller or the job API rather than raw pod definitions, and start trying to go towards that, because that seems to be where the community is kind of going. It's more the request, because there is scheduling raw pods is kind of a problem. There's a lot of self-healing that you don't get, and all these controllers have to kind of do it themselves, which is something we don't really want to do. If that makes sense.
Okay. Oleg is going quiet. So, does anybody have any other questions for Kevin? So, Kevin, the Airflow integration. So, Airflow kind of has its own. Which executor are you guys using? Is this like an executor with Airflow, or?
So, I mean, for the demo, I'm actually running it locally, so I'm using the sequential executor. I believe I think we're using the Celery executor, and I don't know if it's running on Kubernetes. I think it's the Celery executor on Kubernetes is what we're using for Airflow. But we actually created this operator, and then also a different team kind of set up the Airflow. So we need to sync back up with some of them and get a more understanding of how they're running it. But I don't know that quite off my head right now.
Is there like a documentation of how this integration works? I'm assuming it's a CNCF project, so there must be something. Sandbox project.
There is some documentation on our GitHub page for Airflow integration, but it's mostly from a Python docs.
Okay.
We have some examples that kind of show the integration. That is what we've kind of like example by doc. Right. The setup of Airflow is not well documented at all for us. That is sort of kind of left that as an exercise for the reader. Okay. I've heard that we were not trying to get involved with operating Airflow, because I actually do hear that it's almost its own troubles.
Yes. Probably a smart move. Well, thank you so much. And thank you, everybody, for joining. I think this was a very good conversation, a good talk. We will have the recording uploaded on our YouTube channel. And also, if you go to community.cncf.io/Washington-DC, we will also have it linked up there for future. Thank you. And we're going to have our next meetup again in January. We don't have any meetup in the month of December. So it's holidays, so when we come back next year on January 10th, we're going to have another meetup. That's it. Thank you all.
All right, thank you, everyone.
Thank you, Kevin. Yep. Thanks. Bye.
Bye-bye, everyone.